right, let's look at a few examples here of how to do some stoichiometry that aren't just the typical stoichiometry type questions. So, example number 4 says carbonates in the form of antacid tablets can be used to neutralize stomach acid. So then they tell us we've got 25 milliliters of 0.1 molar sodium carbonate reacts with 35 milliliters of hydrochloric acid in a neutralization reaction, producing sodium chloride, water, and carbon dioxide. Okay, write the balanced equation. Okay, so we've got sodium carbonate, Na2CO3, and that reacts with HCl. So this is simply a double replacement reaction where the sodium's going to go with the chlorine and the hydrogen's going to go with the CO3. And CO3 has a -2 charge, so it should be H2CO3. However, anytime you're going to form H2CO3, that will always break apart into H2O and CO2. So that's why they tell you that the products are H2O and CO2. So we've got NaCl, H2O, and CO2. Now in terms of balancing, we've got 1 sodium. Here we've got 2, so we need a 2 there. And then we need a 2 here, and now it's balanced. So part B says calculate the number of moles of sodium carbonate that are present before the reaction begins. So this isn't a stoichiometry problem. They're only talking about sodium carbonate. They're not giving us information about one thing and then asking us about something else. Okay, so calculate the number of moles of sodium carbonate. Well, they give us the concentration, which is molarity, which is moles over liters. So that's 0.100 moles over liters. And then we're going to multiply that by the volume. And remember, we can't use it in milliliters. We have to put it into liters. So 0.025 liters. So now we take our 0.100 times 0.025 equals 0.0025 moles of Na2CO3 sodium carbonate. Okay, so that's how many moles of sodium carbonate we had before we started. And then part C, calculate the number of moles of HCl that are required to react with all of that sodium carbonate. So now we're going from moles of sodium carbonate to moles of HCl. That's our stoichiometry step. So now we're going to take our 0.0025 moles of Na2CO3, and we're going to put moles of Na2CO3 on the bottom because that's what I have up here. And then I'm going to put moles of whatever they're asking me about, moles of HCl on the top. And now I go to my balanced equation. 1 mole of Na2CO3 right here is going to react with 2 moles of HCl right here. And we get 0.0050 moles of HCl. Okay, and that is all you got to do on part C. And then part D says determine the molarity of the hydrochloric acid solution. Well, if that's my moles of HCl, and up here they give me the volume of HCl, we know that we can take 0.0050 moles of HCl and divide it by the volume of the solution, which is 35.3 milliliters. Or 0.0353 liters is how we would have to do that. So I'm going to take 0.0050, I'm going to divide by 0.0353, and I get a final value of 0.142, and that's moles per liter, or molarity. Okay, our next example says what volume of 1 molar NaOH would be required to completely neutralize 25 milliliters of 2 molar hydrochloric acid. Okay, so again, in this case, they're giving us information about one thing. They're giving us information about this, and they're asking us about this. Okay, so we have to use a balanced equation. We have to use stoichiometry to solve a problem like this. So the first thing we do, there's nothing you could do with 1 molar NaOH because that's the only thing they give us about NaOH. But they do give us the volume and the concentration. This is a good indicator. pretty much anytime you get the concentration and the volume of something, you're going to be converting that to moles. So that's what we'll do first. We'll take our 2 molar HCl and we're going to multiply it by the volume. Remember, concentration times volume equals moles. So 2 times 0.025, probably shouldn't need a calculator for that, 0.050, and that's moles of HCl. Okay, and now once you have moles of any of those 4, you can convert from one thing to something else. Let's make sure our equation is balanced. It looks like it is. So now we can put moles of HCl on the bottom and moles of, what are they asking us about here? They're asking us about sodium hydroxide. So we're going to put that on the top. Okay, now again, like the previous problem, I could keep going. I could get grams of NaOH, but they're not asking me for that. They're asking about the volume of NaOH. So I know grams really aren't going to help me at all, so I'm just going to stop at moles. And I have a 1-to-1 ratio, so it's just 0.050 moles of NaOH. Okay, so now I have the moles of NaOH, and remember here at the beginning, they gave me the concentration of NaOH. So remember, molarity equals moles over liters. So I have the moles. I have this part, and I have the molarity, this part right here. All that I'm missing is the volume. And remember, that's what they're asking us for. What volume do we need? So how do you solve for volume when it's a denominator? Remember, you switch those two. So you switch the answer and the denominator. So liters equals moles over molarity. Okay, make sure you do that right. Again, don't lose points on a test because of the stupid math thing. Okay, make sure you understand why that works. So moles go on the top. So 0.050 moles. The molarity goes on the bottom, which is just 1 molar, and then obviously dividing by 1, you get the same number. So 0.050 would be in liters. If you wanted to put it in milliliters, you certainly could. It would be 50 milliliters, moving that decimal point 3 spaces to the right. Okay, and then our last one, dealing with this. What mass of zinc metal will react completely with 75 milliliters of 0.2 molar sulfuric acid as represented by the equation below? So first of all, is this equation balanced? It looks like yes, it is. Everything is a 1. So again, we've got 2 molar sulfuric, or 0.2 molar sulfuric acid, and we've got a volume of 75. So I see the concentration, I see the volume, and so the first thing I'm always going to do is liters, is I'm going to convert that to moles. So 0.200 times 0.075 equals 0.015 moles. And that's moles of what? That's the really important part there. It's really easy to get confused, so make sure you write that down. Again, you're not going to get marked off for it, but this is moles of H2SO4. Okay, so now that we have moles of H2SO4, now we can use stoichiometry to go from moles of H2SO4 to moles of, what are they asking us about here in this problem? They're asking us about zinc, so moles of zinc. According to our balanced equation, it is a 1-to-1 ratio. And now in this case, they are asking us for the mass. So we're going to want to convert to grams now. In the past, we were using molarity and volumes, and they didn't ask for grams, so we didn't need to convert. Okay, but in this case, they are asking us for the mass. So the molar mass of zinc is 65.4 grams. So everything's ones except for that number, so I'm going to take 0.015. I'm just going to multiply it by 65.4, and I get a final answer of 0.981 grams of zinc. All right, and that is our final answer there. So those are just some more examples of stoichiometry, really examples where you're using concentration and volume. to find moles rather than using just grams to find moles. In our next video, we're going to look at some more examples, but we're also going to use gases, and we're going to use PV equals nRT.